Lesson 10.3, Operations with Radical Expressions. Today we will learn how to add, subtract, and multiply expressions with that contain radical symbols. Okay, so let's first look at adding and subtracting expressions with like radicands. This works exactly like adding and subtracting like terms with like variables. So if I have a radical b plus c radical b, the sum would be a plus c radical b. So you add the numerical coefficient and you keep the radical. A numerical example would be 4 radical 5 plus 2 radical 5 would equal 6 radical 5. Subtraction works the same way. A radical b minus c radical b is a minus c radical b. And then just a numerical example, 9 radical 3 minus 4 radical 3 would be 5 radical 3. Okay, let's practice this skill. Number 1, 5 radical 2 plus 7 radical 2 minus 6 radical 2. As you can see, all three of these have like radicands. Okay, so simply combining these terms would give us the sum. So 5 plus 7 is 12, and 12 plus negative 6 would give us 6 radical 2. Okay. Number 2. 10 radical 7 plus 5 radical 11 plus 4 radical 7 minus 6 radical 11. So just like you would with variable terms, you can combine the terms that have like radicands. So let's combine 10 radical 7 with 4 radical 7, and that would be 14 radical 7. And then we can combine 5 radical 11 together with negative 6 radical 11, since they have the same radicand, they're like radicands. And we would get negative 1 radical 11 or just plain negative radical 11. Okay, try number 3 on your own. 3 and 4, actually. Do 3 and 4 on your own. Pause the video now and come back and check your answer. Number 3 is 2 radical 2. And number 4 is negative 2 radical 3 plus 6 radical 7. Remember, we cannot combine terms that don't have the same radicands. So now let's see how we can add or subtract expressions with unlike radicands. And the key word here is simplify. Simplify, simplify, simplify. We have to get the radical expressions simplified before we know if we have a like radicand or not. Okay? So let's start with number 5. Write it down. 2 radical 18 plus 2 radical 32 plus radical 72. Well, we know that these are not simplified. So let's work on simplifying these expressions. Let's start with 2 radical 18. 2 radical 18, we're going to simplify radical 18. So radical 18 is radical 2 times 3 times 3. And so there we have 2 radical 9, which, I'm sorry, let me break down the 2. So we have 2 times 3 radical 2, and so this can be rewritten 6 radical 2. Okay, let's work on 32. 32 is 2 times 4 times 4. There's my perfect square. So I can rewrite it 2 times 4 radical 2. And that would be 8 radical 2, and this is positive. And now radical 72. Radical 72 would be 2 times 2 times 2 times 3 times 3. Okay, so we can say this is 2 times 3 radical 2, and that is 6 radical 2. So now we can go ahead and combine them, because notice with me that these are all like radicands. Now that we've simplified them, we see how they are combinable. So let's go ahead and add these 3 like radicands. And so the answer is 20 radical 2. Okay, let's go on to number 6. So we have 5 radical 54 plus 2 radical 24. Okay, so let's rewrite this one. 5 radical 54, and I think that 54 is 6 times 9, so that would be 2 times 3 times 3 times 3. 2 times 3 is 6, 3 times 3 is 9. I can rewrite that as 5 times 3 times radical 6, which is 15 radical 6. Okay, let's go ahead and simplify 2 radical 24. So we know that 24 is 3 times 8, or 8 times 3, so we have 2. 2 times 2 times 2 times 3. So we can go ahead and simplify that, pulling out the perfect square out of the radical symbol. And so this is plus 4 radical 6. So for number 6, now we can go ahead and add these because we have the like radicand. And so when we add these, we have 19 radical 6. Okay, number 7, try that one on your own. Pause the video, simplify the radical expression, and see which terms you can combine. Okay, so our answer there is negative 16 radical 3. Number 8. Oh, sorry about that. Here we go. Number 8. 3 radical 45 plus radical 20 minus radical 245. So some of these can get a little bit complicated, but go ahead and work them through. And it does require a little practice. So let's take our first term. 3 radical 45. I can break down 45 to 5 times 9. 9 can be broken down to 3 times 3. So it's 3 times 3 times 5. I have a perfect square under the radical symbol. Let's pull it out. So I have 3 times 3 times radical 5. And this would be 9 radical 5. All right, so then we're going to add to that radical 20. Radical 20 can be rewritten as 2 times 2 times 5. And that would be 2 radical 5. And from that we're going to subtract radical 245. Now 245, I'm going to go ahead and use a factor tree just to go through the process with you. So I know for sure that 5 divides 245, and it would be 5 times 49. And then 49 is 7 times 7, and 5 comes down. So there we go. It's 5 times 7 times 7. I can go ahead and simplify that, pulling out the 7. Then it's minus 7 radical 5 again. Notice that these are all like radicands, and we can go ahead and add them together. And so my answer is 4 radical 5. Okay, number 9 on your own. Pause the video now and work on that one. So number 9 is 3 radical 6. Okay, let's work on 10 together. Here we go. 12 radical 3 is already simplified. There's nothing that I need to do with that. However, I have a fraction in the radicand, and so I know that that is not simplified. So I do need to simplify radical 1/3. Let's recall how we do this. Radical 1/3 is radical 1 over radical 3. And so because for a radical expression to be simplified, you can't have a radical in the denominator. We need to make sure that we get rid of that radical symbol in the denominator. So let's recall that we will multiply our expression by a form of 1, squaring that square root of 3 to undo it. And so 3 is my new denominator, and radical 1 times radical 3 is radical 3. And so here I've simplified it to radical 3 over 3, which can also be written this way, 1/3 radical 3. So I'm going to bring down my 12 radical 3 plus 1/3 radical 3. Okay, since we're adding these like radicands, we can look at 12 as an improper fraction with a common denominator of 3. So we can look at that as 36 over 3. So in order to add these, I would add 36 over 3 radical 3 plus 1 over 3 radical 3, and my answer is 37 radical 3 over 3. Okay, let's move on to multiplying radical expressions. Here's the rule for multiplying radical expressions. If I have a radical b times f radical g, what I do is I multiply the coefficients together. A times f is af, and then I'll multiply the radicands together and place them under one combined radical symbol. So a times f is af, and then b times g is bg. Okay, in terms of just a simple problem with numbers so that you can understand how this works, 3 radical 2 times 5 radical 7, I multiply 3 times 5 is 15, and then I'll multiply radical 2 times radical 7, and my answer is radical 14. Okay, let's practice this skill. Number 11, 3 radical 2 times 2 radical 6. So I'm going to multiply my coefficients. 3 times 2 is 6. And then radical 2 times radical 6, remember that I'm always going to need for my expression to be simplified. So I'm going to factor the 6. I have 2 times 2 times 3. And I can simplify that by pulling out the perfect square of 2. So I have the 2 outside of the radical symbol. And so my answer would be 12 radical 3. Okay, number 12. Number 12, we will use distributive property to multiply 3 radical 5 times the expression within the parentheses. Okay, so here we go. 3 times 2 is 6, and it's 6 times radical 25, which can be simplified as 6 times 5, which is 30. Okay, now let's distribute 3 radical 5 times 5 radical 3. So 3 times 5 is 15, and radical 3 times radical 5 would be radical 15. Okay, there's no simplifying that can be done there. So my answer would be 30 plus 15 radical 15. And these two terms cannot be simplified because they're not like terms. They've already been simplified. They can't be combined. Okay, try 13 on your own. Pause the video for a moment to do 13. Number 13 is 42 radical 2. Okay. Number 14 I'll do with you. We're going to multiply 9 radical 5 times 11 radical 15. So I'm going to multiply 9 times 11 first. That's 99. And then I'm going to multiply radical 5 times radical 15, and so I have radical 5 times 5 times 3. So I can pull out and simplify by pulling out that perfect square, and the radical 3 stays in the 3 stays in the radicand. So then I simplify. 99 times 5 is 495 radical 3. Okay, 15 and 16 on your own. Check your answers, please. Number 15 is 12 radical 6 plus 36. And number 16 is 99 radical 15. Okay, number 17 on your own. Number 17 is 15 radical 6 minus 15. Okay. Number 18. Here we're multiplying two binomials with radical expressions. So we will use the FOIL method. We will distribute the radical 3 times radical 15, 3 times radical 12. Then we will distribute negative radical 2 times radical 15, and then times radical 12. Okay, let's work on radical 3 times radical 15 first. What I'll do is I will first write them out, all out expanded, and then simplify. Okay, so that would be radical 3 times 3 times 5. Then I'll distribute radical 3 to radical 12, and it's going to be positive radical 2 times 2. That's 4 times 3 times 3. Okay. Then we will go ahead and distribute the negative radical 2 to radical 15. That would be negative radical 2 times 3 times 5. And then negative radical 2 times positive radical 12 would be negative radical 2 times 2 times 2 times 3. Okay, now let's go ahead and simplify all of these, pulling out all of the perfect squares. Okay, here we go. So my first one has a 3 that I can pull out. I'm just going to identify them all to make it real simple to then simplify. All right, so here we go. This would be 3 radical 5 plus 6. Nothing stays within the radical symbol there. This would be radical 30. It doesn't have a perfect square as a factor, so that is simplified. And this would be minus 2 radical 6. None of these terms have like radicands. They're not combinable, so that is my solution. Although we've done quite a bit of exercises together, this requires a lot of practice. So for homework, in addition to watching the video and taking the notes, I want you to do numbers 5, 8, 10, 13, and 15. And on this page you will do 4, 6, 8, and 14. We will continue discussing operations with radical expressions in class tomorrow. Have a great night. God bless you.